compare polynomial functions. So we're given this f of x is x cubed plus 2x squared minus 3x. And then we're given this graph g of x. Okay, so we want to compare the two. So first we want to graph and see what this one looks like, right? So we can go ahead and do that. We can just plug in values and plug them in for x. So we plug them in. We can plug in -3. We get 0. We plug in -2. -2, we get 6. Plug in -1, we get 4. Plug in 0, we get 0. Plug in 1, we get 1. Plug in 2, we get 9. And then if I plug in 3, +3, that's going to be 36. Okay, so I can graph that, and then I can compare these two and see kind of how they look compared to one another. Okay, so here they're compared to each other. So this is f of x, and this one is g of x. So I can see that, hey, this one crosses the x-axis 3 times, this one crosses 4 times. So those are my zeros. So if I'm looking at some key features, I can say my zeros of f of x, those are at x equals -3, 0, 1. And I can say for g of x, those zeros are maybe like -1. Looks like they're counting by halves, so -1/2, 1, and then at 2, right? So I can compare those zeros. Another thing I can do is I can compare the y-intercepts. So this y-intercept of f of x, that is at 0, and this y-intercept is at, this one is at 2, right? We cross right here at 2. Okay, so those are some key features. Also the end behavior. So as I go more and more this way on f of x, this one goes down, right? So end behavior. Okay, so my end behavior, scroll a little bit down. All right, so end behavior of f of x. F of x, as x goes to -infinity, my graph goes down, so f of x goes to -infinity. And as x gets bigger and bigger and bigger, as I go this way, my graph goes up, right? So f of x goes to infinity. Then I can look at g of x here. Right, so g of x, as x, maybe switch colors there, as x goes to infinity, so as I go this way, my graph goes up. So g of x goes up. And then as x goes to -infinity, as I move to the left, my graph also goes up. So from that, you should be able to tell what type of polynomial function it is. So anything that goes up and up is even, right? And it crosses 4 times, that means it's going to be an x to the 4th. And so that also goes up, right? So those are my kind of key features, my intercepts, my zeros, and my end behavior. And then this new concept is called a relative maximum, a relative minimum. And that's, so notice that these graph f of x keeps on going down and keeps on going up. So there's never going to be a point where it reaches its lowest, right? Or never going to be a point where it reaches its highest, right? Because this keeps going, this keeps going. Well, we have these little peaks here, and then we have these little valleys here, right? Those are called extrema or relative extrema. So those little hills and valleys, we can go ahead and label those points. Now, if you go on to calculus, you actually find out what those are and how to find them. But right now, we're just kind of going to label them because we have a graph so we can kind of see where they are approximately near, right? So this has a relative max. So if I basically isolate this and just cut this off from right here to right here, right, it looks like a parabola right there. So we have a relative max somewhere close to 6, right? So somewhere close to y equals 6. And then also down here, we have a relative minimum. So I would say like 0.5 would be my x value. So that's, and then maybe a 1, y equals 1, the y value. Right, so those are relative extrema. So a relative max and a relative minimum at y equals 1. Then we can look over here Here we have another valley, so that's a relative extrema there, and it's a low point. I would say probably, actually this one over here is negative 1. And this one right here is probably, they're counting by 1, so it's probably y equals negative a half, right? And then up here is probably like, what, 2.5, y equals 2.5, a relative maximum. And then down here, what's that? It's maybe negative 2.5, y equals negative 2.5. So those are called relative because they keep on going. But actually this one down here is actually an absolute because that is the lowest point, right? So this one right here is called a relative because there is a point lower in it, but in this area it's the lowest. Right here is called a relative because we keep on going on and on both sides, but it's relative because in this area it's the highest point in that area. And this is the absolute because it is the absolute lowest point. Okay, so that's kind of a new concept, is relative max or mins is where you have hills or you have valleys, even though your graph might still go on or still go on negative. Okay, so those are kind of the key things that we look for when we're comparing two different functions.